Okay, let's look at some common functions and then we'll look at some piecewise functions. First off, a few common functions that you probably should memorize how they look. Y equals x, I'm just going to graph them. Y equals x, there's your x, is nothing but a line to the origin. That's one common one. Now x squared, you should know by now that's a parabola. And if you don't, parabola is just a big old U. Now y equals x cubed may be a little different. You can use this key for the exponent key if you want to. There's also a cube under the math, but exponent 3. You hit graph, looks like a snake to the origin. Let's just continue. Y equals the square root of x. Square root button's above the x squared key. X. It's a half a parabola on its side. Let's look at the cube root of x. I'm going to go to the math key. You'll see at 4 there's a cube root key, x. And you'll see this is a snake also. We have y equals the absolute value of x. Let's see how we can graph that one. The easiest place to find absolute values is under the catalog, which is under 0. So second 0, or above 0 I should say. Second 0, ABS is the first thing you see. Just hit enter and then type in x and you should see the V. These are just common ones. You better get used to them. Y equals 1 over x. 1 divided by x. It actually looks like this, just so you'll know. It looks something like this. It approaches the both axes, but it never ever gets there. That's a bad one. Let me reverse that. Let me go back here and try that one again. We want to make sure that we get it right. I keep on. I wish my eraser worked, but it doesn't work. So it looks something like this. That's what's really going on. Now let's look at y equals 1 over x squared. So let's just do 1 divided by x squared. And hit graph. And you see that. Once again, I'm going to draw it just so you know exactly what's going on. It looks something like this. It approaches, it gets closer and closer to each x and y axis, but it never gets there. So that's how it looks. So just be comfortable with those. Know how to recognize them. We're actually going to use piecewise functions, or use these common functions to graph a little bit. Piecewise functions, what these are more than one function graphed on the same graph, but they have restrictions. So it's actually one big graph consisting of smaller graphs, but it's considered one graph. So let's look at this example. We got f of x, which is all three of these functions. Now these over here, the numbers on the right, these are domain restrictions. So let me show you how I'm going to approach this. This is probably the best way to do it, to think of it. Now I'm going to use my calculator. We paid, $100 for it, or whatever. So we might as well go ahead and get our money's worth. So let's graph y equals 2x plus 1. Graph. Now it looks like a line, which we should already have known that. Now we don't want to graph all the line. We want to graph it from x less than or equal to 3. So that's 3 and then left a 3. So what I'm going to do is I'm going to hit trace 3, enter, and we see at 3, 7 is the point on y equals 2x plus 1. So what that means is I'm going to 3, 7, and since that's less than equals 2, that means that point's included. So I'm going to put a solid dot there. So I'm going to actually graph it, and just going to be careful how we graph it, like something like that. Now let's go to y equals 4. Let's graph it. Horizontal line. Now that's only from 3 to 5. Y equals 4. So what that means is, I know it's this horizontal line, but I only want to graph it where x is from 3 to 5, but notice there's no lines underneath the inequality signs. So that means I'm going to use open circle there and there. Then I connect those open circles. So I only have the horizontal line from 3 to 5, but 3 and 5 are not included. And then let's go ahead and graph y equals x squared. Now the problem with this thing is, when I type in 5, when I'm going to hit trace, I like to hit trace. Trace evaluates for me. And I type in 5, you're going to see 525. So what I'm going to do is to graph that. Notice it's a parabola. What I'm going to do is I'm going to pretend that we're way up here, and we're going to plot it at 5, 25. So just pretend. We're using our imagination. We're believing we've extended all the way up. So 525. Notice the 5 has a inequality symbol with the line underneath it. So that means the 525 point is included. And then what I'm going to do is I'm going to draw like a parabola type shape. It's actually going to curve a little bit as it goes up. And so that's how the piecewise function would look. We graphed each equation with respect to its given domain. That's the only piece that we graph for each one of those. I don't know how much you'll see of that, but there's an example for you to follow.